Okay, so hello everyone, good evening. So here we shall solve some KCET previous year questions on the chapter laws of motion. If you have any doubts regarding any of these questions or in the solutions, then please write us in the comment section. And if you feel that you have more difficulty in any of the chapters of physics, then also please mention the name of that particular chapter in the comments section so that we may give more priority on it and solve more and more questions on that chapter. And homeworks on every chapter will also be posted on the Sapience education application. So please install our application, the Sapience education application, whose link has been provided in the description. Okay, so we shall start with the first question. So the first question tells that for ordinary terrestrial experiments, the observer in an inertial frame in the following cases is, for ordinary terrestrial experiments, the observer in an inertial frame in the following cases is okay. So we should find that in which of these four experiments the observer is in an inertial frame. A child revolving in a giant wheel. So here it is an accelerated frame. So an inertial frame means that which is moving with a constant velocity, It means that which is not an accelerated frame, Accelerated frame is called as non-inertial frame. So if it is not acceleration, if the frame is not accelerated, then it is called as an inertial frame. So the first option, it is not an inertial frame. And in the option B, a driver in a sports car. So in the option A, a child, when he or she is revolving a giant wheel, then the centripetal acceleration is acting towards the center. So it means that it is an accelerated frame. And in the option B, a driver in a sports car moving with a constant high speed. A driver is in a sports car. He or she is moving with a constant high speed, which is 200 km per hour on a straight road. And then option C is the pilot of an aeroplane which is taking off. The pilot of an aeroplane which is taking off. So if when the aeroplane is taking off, then its velocity is increasing, so it is an accelerated frame. So acceleration is not zero here. And when a driver is moving in a straight road with a constant high speed, when the speed is constant, then the acceleration is zero. So it means that in option B, the observer is in an inertial frame. And in option D, a cyclist negotiating a sharp curve. So when a cyclist is moving in a sharp curve, then the centripetal acceleration is acting towards the center. Then it means that it is an accelerated frame. So it is under acceleration. So only option B is the correct answer, since the frame is moving with a constant velocity. And then in the question 2, here it is told a simple pendulum is suspended from the ceiling of a lift. It is suspended from the ceiling of a lift. It is one lift is there, from the ceiling it has been suspended. When the lift is at rest, its time period is t. The lift is at rest. When the lift, okay, so with what acceleration should the lift be accelerated upwards in order to reduce its time period to t by 2? So g is the acceleration due to gravity. So we know that the time period of oscillation of a simple pendulum um, when the lift is at rest, it means that when there is no acceleration of the frame of reference, so then the time period is given as 2 pi root under L by G, where L is the length of the string of the simple pendulum. And when the lift is accelerating upwards, then the effective value of G we have to take. The effective value of G will be G plus A if it is accelerating upwards with the acceleration A. So then T dash will be equal to 2 pi into L by G effective, which will be equal to 2 pi root under L by G plus A. And this T dash should be equal to T by 2. Reduce its period to T by 2. Okay, so therefore T will be equal to 2 pi root under L by G into 1 by 2. That will be equal to 2 pi root under L by G plus A. So 2 pi and 2 pi will cancel, and root L and root L will cancel. So then if we square both sides, then we'll get L by 4G, that is equal to L by G plus A. So L and L will cancel, so then we can say that G plus A will be equal to 4G. So therefore A should be equal to 3G. So if the lift is accelerated upwards with an acceleration of 3G, then only the time period of the simple pendulum will reduce to T by 2. So option D is the correct answer. So in any of the questions or in the solution, if you have any doubts, then please write us in the comment section. Then it is in the third question, a mass of 10 kg is suspended from a spring balance. A mass of 10 kg is suspended from a spring balance. So spring is there, and the mass M, which is equal to 10 kg, that is suspended from the spring balance. It is pulled aside by a horizontal string so that it makes 60 degree with the vertical. So here, so it is somewhat like this now. It is pulled horizontally the string makes an angle of 60 degree with the vertical when it is pulled aside by a horizontal string with some force F1, suppose. The new reading of the balance is, so the initial reading of the balance suspended, then it is 10 kg weight. So here the actual reading, call it as the weight. The actual weight is 10 kg weight. So this W equals to this is, let's say the natural length of the spring is L, and the amount of extension here, it is suppose X. The extension is suppose X naught. Then we can say that W equal to K into X naught plus L. K into X naught plus L. Where K is the spring constant. K is the spring constant. Then, so this length is L plus X naught. Then this length will be, suppose this is Y. So Y will be equal, so we know that L plus X naught by Y, that is base by hypotenuse, that is equal to cos 60 degree. That is equal to cos 60. So therefore Y will be equal to L plus X naught by cos 60, which is half. So y is equal to 2 into L plus x naught. So this extension is y equal to 2 into L plus x naught. So actually W is not k into x naught plus L. This is k x naught. W is k x naught. W is k into x naught. The new reading. So the new reading, and the mass is not pulled by a spring, it is pulled by a horizontal string. Okay, it is pulled by a horizontal string. Okay, some force F. Okay, then, and it is not placed in the horizontal. Horizontal is not there. So then we can say that downward force is the weight, and this is F1. So then the spring force this is the spring force. Then so let's say this is F. So I can say that here the spring force, if that is F, then F cos 60, F cos 60, that is equal to W. This is 60, then this is also 60. Okay, so therefore F cos 60, that is equal to the weight, that is W, which is equal to 10 kg weight. So therefore F by 2, that is equal to 10 kg weight. So therefore F will be equal to 20 kg weight. So option C is the correct answer. So it means that the new reading of the spring balance is 20 kg weight. Since the spring balance will actually measure the force, the spring balance will measure the force. Okay, so that is option C. Okay, then body of mass 4 kg is accelerated upon by a constant force. Body, it is having mass 4 kg and that is accelerated by a constant force. The force is constant, and it travels a distance of 5 meter in the first second, 5 meter in the first second, and a distance of 2 meter in the third second. The force acting on the body is a body of mass 4 kg that is accelerated by a constant force. So force is equal to mass into acceleration. So acceleration will be equal to the force by mass. Yeah, it travels a distance of the first second, so in t equal to 1 second, and a distance of 2 meter in the third second. It means from t equal to 2 second to t equal to 3 second. Okay, so then so from, it is told that from t equal to 0 to t equal to 1 second, it covers a distance of 5 meters, and in the third second it means that from t equal to 2 second to t equal to 3 second, it covers a distance of 2 meters. The force acting on the body is, so then we can say S equal to ut plus half at square. and so we can say that the displacement in the nth second, that is equal to u plus half a into 2n minus 1. U plus half a into 2n minus 1. So therefore the displacement in the first second s1, that will be equal to u plus, so okay, so u plus half a into 2 minus 1, so that is u plus half a. And then displacement in the third second, that is equal to u plus half a into 2 into 3 minus 1, so that is u plus 5 by 2a. So this u plus half a, that is equal to 5 meters, and u plus 5 by 2a, that is equal to 2 meters in the third second. So therefore if we subtract them, then we will get 5 by 2a. So 5 by 2a minus 1 by 2a, since u and u will get cancelled, so that is equal to 2 minus 5. 2 minus 5. So this will be 4 by 2a, that is equal to minus 3. So 2 to the 6, so a will be equal to minus 3 by 2 meter per second square. So this is the acceleration. Then the force will be equal to mass into acceleration. So then the force that will be equal to mass into acceleration, where the mass is equal to 4 kg into minus 3 by 2 Newton. So that is 2 to the 4, so minus 6 Newton. Option A is the correct answer. The force is 6 Newton, and this negative sign implies that it is a retarding force. It is a retarding force, means it is acting opposite to the initial velocity of the body. So the force is acting opposite to the initial velocity of the body, so it is called as a retarding force. And then the fifth question, body of mass 0.05 kg is observed to fall. It is observed to fall down with an acceleration of 9.5 meter per second square. So the opposing force of air on the body is, so there is an opposing force F, and the downward force is the weight, which is the gravitational force, and then that will be equal to mass, and that will be equal to the net force, which is mass into acceleration. So therefore the net force acting downwards, that is equal to W minus F, which is the retarding force. So therefore F net, that is mass into acceleration, that is equal to the weight, that is mg, minus F, where F is the retarding force or the opposing force of air, opposing force of air. So therefore F, we can write it as mg minus ma, or F we can tell that is m into g minus a. So mass is 0.05 kg into g, that is 9.8, minus the acceleration, which is 9.5, this much Newton. So that will be 0.05 into this will be 0.3 Newton. So that will be 3 5s are 15. So that is 0.015 Newton. So option A is the correct answer. So 0.015 Newton is the required opposing force of air on the body. Then it is told that three concurrent coplanar forces, 1 Newton, 2 Newton and 3 Newton, are acting along different directions on a body. Three concurrent coplanar forces acting along different directions on a body can keep the body in equilibrium. Okay. So we have to find how can the body be in equilibrium. How can the body be in equilibrium? So 2 Newton, 3 Newton and 1 Newton, three concurrent forces. So they can be in equilibrium. We have to apply the sine rule. That is, if this angle it is alpha, this angle is beta, this is angle gamma, then so they are passing through the same point on a, these three forces are acting on a single body in different directions. So therefore now I can tell 1 by sine alpha, that will be equal to 2 by sine beta, that is equal to 3 by sine gamma. So here if so here sine alpha, that we can, so if I say that if I say that alpha equal to 90 degree, then sine alpha will be equal to 1, and then sine beta will be equal to 1 by 2. Sine beta will be equal to 1 by 2. Or we can say that cos alpha so here actually, okay, so here if it is like this, that 3 Newton is acting like this and 1 Newton is acting opposite to that 3 Newton, then here the net force will be 2 Newton. So if the 2 Newton is acting along the direction of 1 Newton force, then only equilibrium can be possible. So if all the three are acting along different directions, then equilibrium is not possible. So the correct answer is option C, that these three forces cannot keep the body in equilibrium. Then it is told that a ball rests upon a flat piece of paper on a table top. A ball rests on a flat piece of paper on a table top. the paper is pulled horizontally but quickly towards the right as shown, then relative to its initial position with respect to the table, the ball, the paper is pulled horizontally but quickly towards the right as shown. Okay, so then relative to its initial position with respect to the table, the ball remains stationary if no friction between the paper and the ball, moves to the left and starts rolling backwards, that is to the left if there is a friction between the paper and the ball, moves forward, that is in the direction in which the paper is pulled. Okay. Okay, so it's pulled horizontally but quickly towards the right relative to its initial position with respect to the table. The ball remains stationary if there is no friction between the paper and the ball. Moves to the left and starts rolling backwards, that is to the left if there is a friction between the paper and the ball, moves forward, that is in the direction in which the paper is pulled. Okay, so here the correct answer is option A. Since why here, if there is no friction, then it will not roll. It will not start rolling. So it will remain stationary if there is no friction in between the paper and the ball. So if there is no friction, then the ball will remain stationary. The ball will remain stationary. And then if friction is present in between the paper and the ball, then the ball will start to roll. The ball will start rolling backwards. It will start to roll backwards. So it means that option 1, the statement 1 and statement 2 are correct. So option A is the answer. Then a boy throws a cricket ball from the boundary to the wicket keeper. A boy throws a cricket ball from the boundary to the wicket keeper. If the frictional force due to air cannot be ignored, the forces acting on the ball at the position X are represented by. Okay, so at the position X, the ball is thrown like this. It will so here frictional force due to air is not ignored, so it will not be exactly a parabolic trajectory. Parabolic trajectory will come only if there is no frictional force of the air. But here frictional force of the air should be considered. So we know that frictional force of the air that acts opposite to the direction of motion of the body. So frictional force of the air acts opposite to the velocity. It acts opposite to the velocity vector of the body. So at the position X, the velocity is along the tangent. The velocity will act along the tangent to the trajectory. So So it means that the frictional force of the air will act opposite to that. It will be opposite to that, and the gravitational force, which is the weight, that will also act. So frictional force of the air is acting opposite to the velocity, and the weight is acting vertically downwards. So it means that the option C is the correct answer. It is like this and like this, means this is the frictional force due to the air, and the weight, which is the gravitational force of the earth, that will act downwards. So in any of the solutions or in any question, any doubts if you have, then please write in us in the comment section. We shall clarify them in the subsequent live classes. Then here in the ninth question, it has been told that block A of mass 2 kg is placed over block B of mass 8 kg. Block B of mass 8 kg is there, and block A of mass 2 kg is there. The combination is placed over a rough horizontal surface. The horizontal surface is rough. Coefficient of friction in between B and the floor. This is block B and this is block A. The frictional coefficient in between block B and the floor, this is 0.5. Say it is mu1 if I tell. And coefficient of friction between block A and B, suppose that is mu2, that is 0.4. A horizontal force that is 10 Newton is applied on the block B. The force of friction between A and B is. So the normal reaction that is acting on the ground, that will be, say it is N1, that will be equal to 8 plus 2. So 10 into mg, that is 10 into g is 10. We have to take g as 10 meter per second square. So 10 into 10 Newton, so it is 100 Newton. So therefore the maximum frictional force that can act on the that can act in between the block B and the ground, that will be equal to mu 1 into n1, that will be equal to 0.5 into 100, that is equal to 50. Okay, so 0.5 into 100, that is 50 Newton. So it means that here 10 Newton is the applied force, but the maximum frictional force, that is 50 Newton, means the maximum static frictional force that can act, that is 50 Newton. So it means the block will not move, it will remain at rest. Since why? If the applied the rule is that if we know that the applied force is less than the maximum static frictional force, then static friction will act, and then friction will be acting as a self-adjusting force. Then friction will be self-adjusting force. It means that frictional force will be equal to the applied force then in that case. Okay, so then it means that the frictional force in between B and the ground, that will also be 10 Newton. It means the whole system will remain at rest only. And since the system will remain at rest, so in between the block A and the block B, there is no friction will act. It means the option D is the answer. Option D is the answer, since no friction will act in between A and B. No friction in between A and B will act. Okay, then here it is told that the resultant of two forces acting at an angle of 120 degree is 10 kg weight. The resultant of two forces, one force is F1 and one force is F2, which thus that they are at an angle of 120 degree. These two forces, F1 and F2, they are acting at an angle of 120 degree, and their resultant is 10 kg weight. Is the resultant force, F resultant. So the resultant of two forces is 10 kg weight and is perpendicular to one of the forces. So the resultant is perpendicular to one of the forces. That force is. Okay. So their resultant is like this. That means that this angle is 90 degree. So we have to find out F1. So that force with which the resultant force is acting perpendicularly, the resultant force is perpendicular to the force F1. So that force F1 is being asked to find. And this angle is 30 degree. Therefore, we can say that the resultant force that is given as 10 kg weight, 10 kg weight. So now F2, this is 30 degrees. So now this component of F2, this will be F2 cos 30. This is F2 sin 30. So now therefore that F2 sin 30, that should cancel with F1. Then only the resultant will come perpendicular to F1. So F2 sin 30 degree, that should be equal to F1. And the resultant force of F1 and F2, that should be equal to F cos 30 degree. F cos 30 degree. So therefore the resultant is given as 10 kg weight. So 10 is equal to F cos 30, which is root 3 by 2. So F will be equal to 20 by root 3. Okay. So F2 cos 30, sorry, F2 cos 30. So F2 is 20 by root 3, and then F1 will be equal to F2 sin 30. So that will be equal to F2, which is 20 by root 3 into sin 30, which is 1 by 2. So that is 10 by root 3. So 10 by root 3 kg weight is the required force. So option D is the correct answer. Then it is told that a person throws balls into air vertically upwards in regular intervals of time of 1 second. Throws vertically upwards regular intervals of time of 1 second. The next ball is thrown when the velocity of the ball thrown earlier becomes 0. The height to which the balls rise is okay. So it means that the next ball is thrown when the velocity of the ball thrown earlier becomes 0. Then the next ball is thrown. It means that the highest point is reached by the ball in the time interval of 1 second. So 1 second is required to reach the highest point. So the heights to which the balls rise is, so here g we have to take it as 10 meter per second squares. Then you can say that the height has been asked, height. So h will be equal to 2 ut. Okay, you can say v square equal to u square plus 2gh, and here v equal to u minus gt. So therefore 0 equal to u minus g into 1. So u equal to g actually. So therefore h will be equal to v square minus u square by 2g. So that is v square is 0. So this is minus, okay, since g is acting downwards, vertically downwards, so g I have to take it as the negative sign. So this will be 0. So h is equal to v square minus u square by minus 2g. So that is u square by 2g. So u is g square by 2g. So that is g by 2. So g by 2 means 10 by 2, that is equal to 5. So the heights to which the balls rise is 5 meters. All the balls will rise to a height of 5 meters above the ground. So option A is the correct answer. Then here it is told that a body of mass m is traveling with a velocity u. A body of mass m is traveling with a velocity u. When a constant retarding force F is applied, it comes to rest after traveling a distance S1. After traveling a distance S1, it will come to rest. The mass will come to rest, that is v equal to 0. So the initial velocity is u, and after traveling a distance S1, it will come to rest. If the initial velocity is 2u, okay. So the constant retarding force is F. So if it is told, if the initial velocity v0, that is equal to 2u, with the same retarding force F, then the distance traveled before it comes to rest, that will be equal to S2. Then we have to find the relation in between S1 and S2. So S1 will be equal to ut minus half at square, or we can say so here the time has not been told, so we should not use this equation. We should use the equation of motion, which is v square equal to u square plus 2as. So in the first case, the final velocity is 0, so 0 square equal to u square and plus 2a. So here acceleration should be given as minus f by m, since the force is acting in the negative direction, since it is a retarding force. So the direction of the initial velocity, let's suppose it is towards right, so that the direction towards right should be taken as positive, and the direction towards the left in which the retarding force is acting, that should be taken as negative direction. So the force acting is minus f, so acceleration is minus f by m, it means that the retardation is f by m. So that we can say that it is u square minus 2f by m into, and s is here s1. So therefore here you can say that s1 equal to mu square by 2f. Since why 2f by m s1, 2f by m s1, that is equal to u square, so s1 will be mu square by 2f. And then for the second case we can say that, so this we have done for the first case, and then for the second case, if the initial velocity is 2u, then the displacement is s2 before it comes to rest, and the retarding force is remaining the same, which is f. So therefore 0 square, that will be equal to u square, so 2u whole square plus that is minus, sorry, it's a mistake. Okay, so let's do it from the beginning. So the initial velocity is u and the retarding force is f, and it travels a distance s1 before it stops. Its mass is m, so therefore the retarding force is f by m. So the retarding force is f and the retardation is f by m. Therefore I can say that v square equal to u square plus 2as. So I can say that 0 square will be equal to u square minus 2f by m into s1. So s1 will be equal to mu square by 2f. And in the second case, if the initial velocity is 2u, then the displacement is s2 before it comes to rest, and the retarding force is remaining the same, which is f. So here also the retardation is f by m. So here I will tell 0 square will be equal to u square minus 2. So it will be 2u whole square minus 2f by m into s2. So therefore 2f by m into s2, that will be equal to 4u square. So 2 and 2 will cancel. So therefore s2 will be equal to 2mu square by f. 2mu square by f. So therefore s2 will be equal to 4s1. S2 will be equal to 4s1. So option D is the correct answer. Then in the question number 13, it has been told that a block kept on a rough surface starts sliding when the inclination of the surface is theta with respect to the horizontal. It's theta with respect to the horizontal. A block is kept on a rough surface. It is sliding with respect to the starts sliding. Okay, it starts sliding. Okay, then the coefficient of static friction between the block and the surface, let's say it is mu. So the normal reaction here, it will be equal to so this is mg, then the component which is of mg which is perpendicular to the incline, that will be mg cos theta. Since why, if this angle is theta, this angle will be also theta, and then the component of mg along the incline will be mg sin theta. So therefore the static frictional force which is acting above the incline, that is mu n. Here n will be equal to mg cos theta, since why the block cannot move in the direction perpendicular to the incline. So since I will tell, since f net, that is equal to 0 perpendicular to the incline, the net force should be 0. And then the opposing force, which is the frictional force, which is mu n, that will be equal to the applied force, which is mg sin theta. So therefore mu into mg cos theta, that should be equal to mg sin theta. Mg and mg will cancel out, then I can say that tan theta will be equal to mu. So then theta will be equal to tan inverse mu. So mu will be equal to tan theta, means the frictional force, the coefficient of static friction in between the block and the surface will be equal to tan theta. So option B is the correct answer. So in any of the questions or in the solution, any doubts if you are having, then please write us in the comment section. And here the x and y components of a force acting at 30 degree to the x-axis are. So the force is acting at an angle of 30 degree to the x-axis. It means it is at an angle of 60 degree with the y-axis. So the x component of the force, that will be equal to f cos 30 degree, which is equal to root 3 f by 2, and the y component of the force, that will be equal to f sin 30 degree, that is equal to f by 2. So therefore the x component is root 3 f by 2 and y component is f by 2. So option C is the correct answer. The force F is actually written as fxi cap plus fyj cap. So here the x component is root 3 f by 2 and y component is f by 2. Then it is told that in a lift moving up with an acceleration of 5 meter per second square, a lift is moving upwards with an acceleration of 5 meter per second square, a ball is dropped from a height. A ball is dropped from a height of 1.25 meters. 1.25 meters. The time taken by the ball to reach the floor of the lift. The time that it will take to reach the floor of the lift. Okay, so it is going upwards with an acceleration a. So therefore the G effective will be equal to, which is acting vertically downwards, that will be equal to G minus A, sorry, G plus A, G plus A. So G effective will be equal to G, that is 10 plus 5, that is equal to 15 meter per second square. So we can say that S is equal to UT plus half AT square. So it is being dropped, so U will be equal to 0 since the ball is dropped from that height. Here S, which is the height from which it is dropped, that is 1.25 meters, and acceleration is same as, the acceleration is the G effective which you have to use here. You can call it A1, okay. That is equal to G plus A, which is equal to 15 meter per second square, and we have to find the time T. So we can say that 1.25, that is equal to half AT square, which is half into 15 into T square. So T square will be equal to 2 into 1.25 divided by 15. So T square will be equal to 2 into this, so this will be 2.5 divided by 15. 2.5 divided by 15. 5 3 are 15 and 5 5 are 25. So T square is equal to 1 by 6, since 0.5 is half. So T will be equal to 1 by root 6. 1 by root 6. So 1 by root 6 is approximately equal to, so now T, so I can say it as root 6 by 6 also. So root 6 is approximately, so root 5 root 6, that is equal to 2 point something. So root over 6.25, that is equal to 2.5. So slightly less than that. So in root over 5.76 is 2.4. So that is approximately 2.45, I can tell. 2.46 we can tell approx, divided by 6. So that is 0.4. 6 4 are 24 and 0.41 second approx. So option D is the correct answer. 0.4. 0.4 second is the approximate value of the time which is taken by the ball to reach the floor of the lift. Then it is told a person is driving a vehicle at a uniform speed of 5 meter per second. A person is driving a vehicle with a uniform speed of 5 meter per second on a level curved track, of radius 5 meter. The coefficient of static friction in between the tires and the road, that is 0.1. Will the person slip while taking the turn with the same speed? You have to find, will the person slip while taking the turn with the same speed? So now here the frictional force is providing the necessary centripetal acceleration. So that is v square by mv square by r. And frictional force is mu into n. N is equal to mg. So mu mg, that is equal to mv square by r. So frictional force that should be greater than or equal to mv square by r. Since the maximum static friction force should be Fs max, that should be more than mv square by r, else it will slip. So I can say that v square should be less than or equal to v square should be less than or equal to mu rg. So v should be less than or equal to square root of mu rg. So now therefore the value of mu rg that we have to find, so that is mu is 0.1, radius is 5 and g is 10. So that will be equal to 5 meter per second sorry, so root over mu rg, that is equal to root 5 meter per second. But here the velocity, the uniform speed with which the person is trying to take the circular turn, but the person tries to make the circular turn, make the turn with a speed of 5 meter per second. So 5 is obviously more than mu rg, which is more than square root of mu rg, which is root 5. 5 is more than root 5. So it means that the person will slip. So choose the correct statement. So here it is that, so you can say that v should be less than or equal to root 5, or you can say that v square should be less than or equal to 5. V square, a person will slip, so it means that the person will slip if v square is more than 5. So I can say that the person will slip while making the circular turn if v square is greater than 5 meter per second. Actually it should be meter square per second square. So v square should be, v square is the person will slip. So option D is the correct answer. But here the unit should have been given as meter square per second square. Since this is not the speed, v square is not the speed, it is the square of the speed. Okay, so then an aeroplane executes a horizontal loop, and an aeroplane executes a horizontal loop at a speed of 720 kilometer per hour, 720 kilometer per hour, with its wings banged at 45 degree. What is the radius of the loop? The wings are banged. The wings are banged at an angle of 45 degree to the horizontal. 45 degree. So it means that here the friction of the air, or the normal force of the air, is acting at an angle of 45 degree with the horizontal. Let's say it is n. So then this is 45 degree. So I can tell n cos 45 degree, that is providing the necessary centripetal force, which is Fc, which is equal to mv square by r, and the vertical component of this normal force of the air, that is n sine 45, that is trying to balance the weight of the aeroplane, which is equal to mg. Then it is told what is the radius of the loop. Radius of the loop has been asked. So therefore here we can say that n sine 45 degree, that is equal to weight, which is mg, and n cos 45 degree n cos 45 degree, that will be equal to mv square by r. So n sine 45 is n by root 2, and n cos 45 is also n by root 2. So they are equal. Therefore you can say mv square by r, that is equal to mg. So therefore m and m will cancel out. Therefore we can say that r equal to v square by g. So v will be equal to 720 kilometer per hour. Okay, so 720 kilometer per hour. So I can say that it is into 5 by 18 meter per second. V is equal to 720 into 5 by 18 meter per second. So it's 18 18 4 is 72, 40, so that is 200 meter per second. So that will be 200 square, so 200 into 200 divided by 10. So that is to the 4, so 4000. R is 4000 meters, R. The radius is 4000 meters, the radius of the loop, or I can say it is 4 kilometer is the radius of the loop. So option B is the correct answer. So in any of the questions or in any steps of the solution, if you are unable to understand or any doubts if you have, then please write us in the comment section. Then in the question number 18, it is told that a stone of mass 0.05 kg, it is a stone of mass 0.05 kg, it is being thrown vertically upwards. It is being thrown vertically upwards. What is the direction and magnitude of the net force on the stone? It's thrown vertically upwards with an initial velocity u. What is the direction and magnitude of the net force on the stone? What is the direction and magnitude of net force on the stone? What is the direction and magnitude of net force, okay, on the stone during its upward motion? So the net force acting is only the gravitational force, which is the weight. So the net force acting on the stone during its upward motion, it will be always vertically downwards, which is the weight. So it is equal to mg. So g, so 0.05 kg into 9.8. So that will be 5 8 is 40, 5 9 45, 49. So 1 2 3, so that is 0.49 Newton. 0.49 Newton is the weight or the gravitational force which is acting vertically downwards. So option A is the correct answer. Then it is told the maximum acceleration of the train in which a 50 kg box lying on its floor will remain stationary. So one train is there. So in the floor, on the floor of the train, we have one 50 kg box. The mass of the box is 50 kg. It is lying on the floor. It will remain stationary, and it is given that the coefficient of friction, so when it is moving forwards, then the pseudo force that is acting, that is when a train is moving towards the right, then the pseudo force is acting towards the left, which is equal to ma. If the train is moving forwards with an acceleration a, then the pseudo force will act towards the left on the box which is lying on the floor of the train. So ma, that should balance with the frictional force, which is mu n, and the normal reaction will be obviously equal to mg. N is equal to mg. So it means that ma, that should be equal to mu mg. And here the coefficient of friction is given as coefficient of static friction in between the box and the train's floor, that is equal to 0.3, and g is equal to 10 meter per second square. So here m and m will cancel, then a will be equal to mu g. So therefore acceleration will be equal to mu is equal to frictional coefficient of friction, that is 0.3 into g, that is 10. So acceleration is 3 meter per second square. So option B is the correct answer. So this is the maximum acceleration that the train can have, for which the box will remain stationary on the floor of the train. Okay. Then question number 20 is a body of mass 50 kg is suspended using a spring balance inside a lift at rest. A lift is kept at rest. A body of mass 50 kg is suspended. Its mass is 50 kg, that is suspended inside a lift which is at rest. It means its acceleration is 0. If the lift starts falling freely, it means its downward acceleration is g. Then the reading of the spring balances. So if it so the spring balance here, so the spring balance will always measure the apparent weight. So when it is at rest, then it will measure the actual weight, and when it is falling freely, then the g effective will be equal to g minus g, that is equal to 0. Then the apparent weight will become 0, m into g effective, that is will be equal to 0. So therefore it will measure the apparent weight, therefore the reading will become 0. So option A is the correct answer. Then it is told that a block rests on a rough inclined plane. A block is there which rests on a rough inclined plane. A block is there which rests on a rough inclined plane which makes an angle of 30 degree with the horizontal. The coefficient of static friction mu s between the block and the plane, that is 0.8. So if the frictional force on the block, that is 10 Newton. 10 Newton is the frictional force acting, and the maximum static frictional force that can be equal to mu n, which is mu mg cos 30 degree. Since this will be n and this will be mg will act vertically downwards, and the component of mg which is normal to the inclined plane, that is mg cos 30, and the component of mg which is acting along the inclined plane, that is mg sin 30. So therefore n, since the block cannot move in the direction perpendicular to the inclined plane, so n will be equal to mg cos 30. So therefore mu is 0.8 into m, that is so the mass of the block only that is asked. So here the frictional force acting is this. So the frictional force, the maximum frictional force is 10 Newton, and that is equal to it into mg. G is 10 into cos 30, that is root 3 by 2. So then 10 and 10 will get cancelled, and m will be, so that is 0.4. So m will be equal to 1 by 0.4 into root 3. So therefore m will be equal to, that is 4 by 10, so 10 by 4 root 3, so 2 to the 4, 2 5s are 10, so that is 5 by 2, that is 2.5 by root 3, that is 1.73. So approximately that is 17 2s are 34. So okay, so here actually first we should find, so mu is 0.8 and tan 30, that is equal to 1 by root 3. the applied force is mg sine 30. So if mg sine 30 is greater than or equal to mu mg cos 30 degree, then only the block will slide. The block will slide downwards. Slide downwards. So mg and mg will get cancelled. So if that mu is less than or equal to tan 30, that is 1 by root 3. So 1 by root 3 is approximately, that is root 3 by 3, I can say, that is 1.732 divided by 3, that is approximately 3 5s are 15, 3 7s are 21, 3 7s are 21 approximately. So mu is 0.8, so here 0.8, that is more than 0.577. So here we can see that mu, which is 0.8, that is greater than 0.577. So therefore the block will not slide downwards. The block will not slide downwards, and the maximum static friction will not act also. And the maximum static friction will not be acting. Okay. So therefore the frictional force will be same as the applied force here, which is equal to mg sine 30 degree. So now therefore the frictional force, which is equal to which is 10 Newton. So 10 Newton will be equal to mg g is 10 into sine 30, which is half. So 2 5s are 10. So m is equal to 2. So m is 2 kg. So the mass of the block is 2 kg. So option B is the correct answer. So in any of the steps, if you have any doubts, then please write us in the comment section. Then question number 22. Man weighing 60 kg. Man is weighing 60 kg. His weight is, his mass is 60 kg. Is in a lift which is moving downwards. With an acceleration 1.8 meter per second square. The force exerted by the floor on him, means the normal reaction of the floor, that is being asked. You have to find the normal reaction of the floor. So his weight is acting downwards and it is falling down with an acceleration. The lift is moving down with this acceleration. So I can say that the net force is equal to mass into acceleration, which is equal to the weight minus the normal reaction. So therefore the weight, which is mg minus n, that is equal to ma. So n will be equal to m into g minus a. So that will be equal to g, that is 9.8, g we can say that is 9.8 meter per second square. So therefore n will be equal to m, which is 60 kg, into g 9.8 minus 1.8, which is 8. So 60 into 8, which is 480 Newton. So the force exerted by the floor on him, that is 480 Newton. So option B is the correct answer. Then here it is told that an object with mass 5 kg is acted upon by a force an object is of mass 5 kg is acted upon by a force which is minus 3 I cap plus 4 j cap Newton. If its initial velocity at t equal to 0, initial velocity equal to 0 is v vector, which is 6 I cap minus 12 j cap meter per second. The time at which it will have a velocity along the y-axis is So now, therefore, we can say that final velocity, let's say it is v1, so v1 that will be equal to we can say it is v plus at, where v is the initial velocity here and v1 is the final velocity. So final velocity, the its y component of the final velocity, that should be 0 here. It is, so here it is asked that if v1y that is equal to 0 at time t equal to t, then that time t we have to find at the time at which it will have a velocity along the y-axis, means, okay, so it means the x component of the velocity that should be equal to 0. X component of the final velocity that should be 0. Okay, so therefore v1 vector that is equal to 6 I cap minus 12 j cap minus a, so acceleration is equal to f vector by m, so therefore acceleration vector will be minus 3 by 5 I cap plus 4 by 5 j cap, this much meter per second square, or we can say Newton per kg. So this will be plus v plus, that is minus 3 by 5 into I cap plus 4 by 5 j cap into t. Now therefore v1x, x component will be 6 minus 3t by 5, 6 minus 3t by 5 I cap. It means that v1 vector I can say 6 minus 3t I cap, then plus minus 12 plus 4t by 5 j cap, this much meter per second. So now therefore v1x, which is equal to 6 minus 3t by 5, that should be equal to 0. So it means that 3t by 5 that should be equal to 6. So 3 2 is 6. So it means that t should be equal to 10 seconds. So it means that at t equal to 10 seconds, the final velocity will have only y component, will have velocity only along the y-axis, and x component will become 0. So option D is the correct answer. Then we shall solve the last question of our live class. That is, here it is told that one end of a length of a string of length L is connected to a particle of mass m, and the other to a small peg on a smooth horizontal table. Okay, so one smooth horizontal table is there, and the string of length L is connected to a particle of mass m. One end is connected to a particle of mass m and the other to a small peg on a smooth horizontal table. This is of length L, and if the particle moves in a circle, with speed v, the net force on the particle directed towards the center is T is the tension in the string. Okay, T is the tension in the string. It is traveling with a speed v. Okay. So here T, the net force acting on the, so the tension force is acting towards the center. So T is equal, it provides the necessary centripetal force, which is equal to mv square by L. So T equal to mv square by L. This is only the net force on the particle which is acting towards the center. So we can say T or mv square by L, but we cannot add or subtract them. So T is the net force. The tension force is only the net force which is acting towards the center. So option C is the correct answer. So hope you have understood all the solutions of these questions, and if you have any questions or any doubts in any of these solutions, then please write us in the comment section. And so thank you everyone. we shall end the live class here. And all the homeworks we shall upload in the Sapience education application. Please install it, and from the homeworks also, any doubts if you are having, then you can write us in our comments section. We shall clarify them in the subsequent live classes. Thank you.